Okay, continue on with lesson 3-4. Lesson 3-4 from the lesson book. We're going to look at a problem situation. Here's an example of data. This is of the minimum wage, federal minimum wage from 2005 to 2015. So you can see the year and then what the minimum wage was or is for that year. It's currently a hot topic right now in terms of raising the minimum wage. And so what we're going to do is we're going to use a linear equation to model the situation. So here's the data. Here are the points for the minimum wage. And if we wanted to find a model, which is a linear equation, one way is to pick 2 points and then find the equation of the line that goes through those 2 points. So I picked 2 points for us, 2005, 2015, and I'm finding the equation of a line. The line is an approximation of how the minimum wage is increasing. You can see from year to year the minimum wage is increasing at some approximate constant rate of change. So in this case, we're going to find y equals mx plus b. This time, though, instead of using y and x, we're going to use t and w, minimum wage, and then time. And so then looking at those values right there, we could go ahead and first calculate the slope of this, right, using this. In order to find this model here, we have the mathematics here looking at, to find the slope between these 2 points, you get 0.212. To solve for the y-intercept, you would substitute one of these points into the y equals mx plus b equation over here, solving for b, and so you would end up with 629. So that's where this equation comes from. And again, instead of y and x, I'm using w and t. You would see what this equation means here. This 0.212 means 21 cents per year that the minimum wage seems to be increasing. And then the y-intercept would be the minimum wage in the year 2000, since we used 15 and 5 as the data points instead of 2000s. And so that's what that would mean. And then you could go ahead and then make predictions by substitute values, and then also predict when it's going to be $15, which I think many people are talking about. This is federal, but in California, minimum wages are higher. Many people already have $15 an hour, but in terms of the federal, we're predicting in 2041 if we have the same rate. And then we have other, again, situations. This is growth rate of boys, and so you can then see the mathematics I did. The 2 points I chose in this case here, instead of y equals mx plus b, I'm using a and h for age and height. And then you go ahead and do similar mathematics that we've done to solve for the missing variables. Here the slope would mean centimeters per year, and then you could go ahead and make a prediction for that. As you can then see, again, the height of a boy from 2 to 15, you can see it's an increasing value, and you can see about 7.25 centimeters per year. You would make predictions here. And then again, questions about how we use these equations. This is pretty much only good for the years of, we would say, probably between 2 and 15. And would you use it to predict the height of a 16-year-old boy? How confident are you? You can use it to make a prediction, but since it's not on the chart, it's hard to say we would use it, right? How reliable it would be. And then we wouldn't use it for a 30-year-old, because if you did substitute, looking at someone who's 7 feet tall, 8 feet tall. So it's not likely that's the predictions, because height does level off at some point. So this is only good for a certain set of values, which we would call the domain, which is in this question here. What's a reasonable domain? Domain is what are the good x values we would use for this equation, right? And then in this case, we would say probably from 0 to 18, even though it goes to 15, we could probably say boys stop growing around 18 years old. And then looking at the other values here, here's the answer to this, the inequality for the 95th and the 5th percentile for a 9-year-old boy. When we look here at 9-year-old, you can see the values from here to here. That's where those numbers come from about 145 to 124. You can see where that's the 5th percentile, 95th percentile, kind of where everyone is in between, all the boys. This line is on the average or the median value. And so that's what you would say there. And then if a lost child is found 145 centimeters tall, how old would they be? So in this case, here's 145. We're guessing somewhere here, right? Somewhere in this age bracket, somewhere between 9 to 13 years old, somewhere in there for someone who is that tall, 145 centimeters. Again, you can use your graph to make a prediction like that. There we go. Problem 3 is a more difficult one. I'm just going to leave it here. I'm not going to explain it. If you want to skip it, you can. It's more of a difficult situation here because of the science behind it. We wouldn't test you on the kind of the science behind it, but I'll leave that up. And that's it.